a smart contract for a blockchain is just a computer algorithm. And we can capture the terms of the incentive contract in the computer algorithm, meaning is the latest drill pipe connection time better than the moving average of the previous 6 months moving averages? Yes or no. If it's better, then get a bonus, and if it's worse, incur a penalty. And we could use our IoT platform that we built to measure exactly how long the latest drill pipe connection had taken. We need 7 pieces of data off the rig. So you use that IoT data to trigger the terms of the performance contracts. And now you've just automated the contract, and you can store the results in a block. So you take the legal contract, the smart contract, the base data, and the results of the transaction, and you put it in a new block, and you add that on to the end of the blockchain. And now you've got a record of an unchangeable or immutable record of what has happened, and you can use that to create trust in the untrusted environment and automate a payment of the bonus or incur a penalty. So in a nutshell, that's what we do. No cryptocurrencies, no mining, nothing like that. We built an industrial blockchain from the ground up because the fintech blockchains don't scale for what we're trying to do. They estimate that by being able to automate the water haulage for their whole fleet in North America, they can save $4.5 million a year. Or putting it a different way, they can save $85,000 a week. And so what we do is we measure how much water was picked up from a wastewater tank. We measure how much water was put in the truck, and we measure how much water is put into the saltwater disposal well, and we do a cross-reference between them. And as long as the result is within 1.6%, then we automate a payment between them. So it's a very simple algorithm, and we're looking in the price book, and so it's a significant saving. And that's one point to make here, which is I think very important, is there is not a win-lose here, it's a win-win. This was a 520-page contract. It contradicted itself in 35 different places. And one of the interesting side benefits that nobody really expected was that it forced us to be much more specific about what the contract terms are. So what is the definition of midnight? What is the definition of daily? What is the definition of a delivery? I mean, what is the receipt and delivery point? And so you have to go through with each counterparty and say, what is the definition of each of these things? And what is the commercial intent of the contract? Now you've got one source of truth. You don't have the oil company and the drilling contract having 2 different versions of the truth, which means that you have disputes. So by having one version, to answer your next question, which is probably what is that source of truth? And so when you're sitting down with 2 companies, you have to agree what that source of truth is. So I mean, one company may say we have a remote operating center and that's the reliable data. But the other company is going to say, well, we don't trust that data. That's your data, and you've manipulated that data, so we don't trust it. So you typically have to go upstream. You have to go to the operation, which neither side can change because that's how the rig is operating, or the well site, or the whatever it is. You go upstream you get a source of data that both companies trust. The 5 different categories of contracts. I think there's going to be industry contracts. So for example, I talked about the oil and gas consortium. They own the IP to that smart contract. We don't. We wrote it, but they own it. So they can do whatever they want with it. There's going to be corporate contracts. So what we're seeing is our customers saying, we want to standardize on this smart contract, so let's say drilling, and I want to use it everywhere in the world. And so we train their IT guys how to write these smart contracts. So they are now self-service. There's data gumbo contracts, ones that we release. I think there's going to be open source contracts. So universities, for example, are going to have smart contracts. They're going to have computer science departments that use a version of our blockchain for experimentation and teaching students how smart contracts write and how you get the data and everything else. And then there's a there's a fifth one, which is service providers and legal companies. So, excuse me, they can start to release smart contracts to implement the legal intent or the commercial intent of their legal contract. So there's law firms setting up practices for writing smart contracts. So I think that's five categories of contracts. The biggest challenge, quite honestly, was getting involvement from all the right people, because they're all busy doing their day jobs, and now they were told to go back and look at a contract they'd already signed. So getting commitment from each side and getting the right people to show up in the right meetings, to be perfectly honest, that was the hardest part. The other piece, which is, change management, is actually the hardest part of implementing these contracts, because when you take a contract live, we have something called the trust session. And the reason that's weird is because imagine you're driving a car, it's an autonomous car, and then this person says, take your hands off the steering wheel, and the car is going to drive itself. So in our case, you're used to signing field tickets, signing invoices, running around, chasing around, and now we say, and now you have nothing to do. And so what do we do now? And so the whole business process improvement process is actually going to be an interesting change of what does this mean for companies?
Estonia has been a pioneer in e-government since the beginning of this millennium. And in a snapshot, what it really comes down to is that Estonia has used digital technologies to make government automated, easy to use, transparent. And so some of the key statistics people talk about is that really pretty much all government services are online. The only exception is you can't get married online. You do have to go present yourself. You can't get divorced online. You have to present yourself, although when you get divorced, you can present yourself separately to an official. The divorcing husband and wife don't have to go together. If you want to sell a house, you can't do that online. Everything else can be done completely digitally. About a third of the population, when we have elections, votes online. It takes 20 minutes to start a company. The cabinet meetings of the government are done digitally. It takes 3 minutes to file your taxes. So we've managed to build a really well-functioning public administration by using digital tools and technology. These are easy, but it actually, when it's easier to start a company, when you can't bribe anyone because you can't bribe a computer, when you have transparency on whether a company is registered, whether they have a certain authorization, all of these things that slow down, how a business works in terms of bureaucracy and paperwork, they go away. Blockchain we use is very different to the principles of how Bitcoin works. And primarily in Estonia, it's used to safeguard the integrity of really key government systems, your e-health system, land register, I mentioned, some other systems. So for instance, in the health registry, all of the kind of central databases and the logs are backed by blockchain, so that you know that the data haven't been altered, you know that all the regulations on data protection have been followed. Similarly, the State Gazette, which is where the laws actually get published. Every act has the integrity of the files backed by blockchain, and there's a regular check to make sure that the data that people see when they look at the State Gazette with the official laws is actually the correct data that hasn't been altered. Because you can imagine someone actually literally going and hacking the laws of the country, and then you have a real problem. And so two of our co-founders, Mert Puldas and Ahto Sarabera, who were two Estonian cryptographers, at the same time that Bitcoin basically was released, were building their own version of blockchain. And their version focused much more on the idea of having a formal mathematical proof and less on this idea that things had to be distributed. So they said, if I have a mathematical proof that what I'm saying is true, then anyone can verify. I don't actually have to have a million servers running everything. I can have the infrastructure be centralized. And so what we've done since then is we've built our own parallel infrastructure that does all the things that other blockchains like Ethereum, like Hyperledger do, but they do it in a somewhat different way, where the actual infrastructure is more centralized, but it's backed by math that anyone can verify and that you can verify very easily. And that lets us do everything that other blockchains let you do, but in a much more scalable way. And we would argue in a more secure way, because you're not saying, well, I trust this because 50 servers say it's true. You're actually saying, I trust this because I have a mathematical proof that's completely public that I can verify at any time. is when we come to data protection questions. Ideally, there's very little additional data protection implication from the blockchain itself, right? Because it's a system on top of that that's used to verify data that has cryptographic proofs around the data. You're not holding the data in the blockchain. So this whole question of data protection in blockchain doesn't necessarily apply, because we're not actually taking sensitive data and exposing the raw data to other parties. And indeed, in many ways, we think it allows you to reduce the exposure to personal data, because when you need to verify data, you actually are able to verify, instead of having to see the raw data, you can verify that a process has been conducted. So you can get into all these engineering solutions where you allow everyone to hold on to their sensitive data without actually sharing the data themselves. You have a thin layer of a cryptographic proof on top of that, and that way you get the business intelligence of data sharing without having to share the data.
Our client have given the pilot the interface to this blockchain media, where immediately once the vessel commander has confirmed that the air vessel is ready, the plane is ready to be fueled, then the fueling company immediately confirmed to the bank that fueling is about to start. The bank immediately confirms in the same blockchain that the money is in the account, and the whole fueling process starts faster and without unnecessary calls or mistrust to each other's data, or phone confirmation over the intent of the pilot and things like that. Verification history goes into blockchain so that all the government bodies can transparently and objectively see what was the last verification for any particular aggregate, any particular mechanism. Why is it important? As you all can imagine, oil and gas is a pretty high risk industry, not only in terms of spillages and fires, but unfortunately also human lives. So in most of the oil and gas countries that I have worked with, there were pretty strict governmental control on the usage of the equipment, on the time that passed since the last planned maintenance or the last break fix maintenance, and the management of those records, and knowing which unit is to be operated for how many months without a maintenance and which one has to go off production is very critical, not only for the production itself, but also for the regulator. This data is not always retained properly. It's paper-based with all the consequences, and you cannot put it in a database that is controlled by the oil company itself, because the regulator is not going to believe in it, and you cannot hold it on the government level, because then the commercial parties will not believe in it, will not trust it. Hence, again, a case for blockchain when nobody doesn't have a need to trust anybody. There's a joint, shared, distributed knowledge of for the service maintenance. The reality was that most of the companies, if these projects were to happen, I think most of them were either private or they would be using the Russian public blockchain. So the Russian government is designing and has designed, in a way, its own public blockchain, but with the crypto algorithms that are certified by the Russian special services. So not using the public crypto algorithms. So that would be that. Clearly, once you start operating, once you become a node in a larger network, there's a cost factor involved, like you said. So for most of these cases, it was just private.
Our clients are mainly seeing a blockchain as a part of a Lego of business models, right? So, for example, okay, we can solve, for example, smart contracts, but what will be the result? How can we conduct it with the cargo tank, or using other technologies to increase the value of the results of this initiative, right? So that's what I'm seeing here. I'm talking to the CDOs in Brazil.
In projects with blockchain, they open a dialogue between companies. This is something very interesting, different in other type of projects, and including they open a dialogue with competitors. to creating a possible to new cooperation, and probably the cooperation doesn't work before without these situation, without this new paradigm. And I think in my opinion, maybe this technology is more than a technology, and maybe blockchain is opportunity to discuss a new ecosystem based in something different than a power or a centralization, and to try to develop something new, putting a reconstructor chain value to trying to get value to open to operating together. Maybe you are a competitor in some case, but you can develop something, a project or a situation, then it's better to cooperate than compete. And I think this is something very different when you talk about using the blockchain technology, and it's more about the new way to think more than a technology itself.
In my opinion, it's definitely the customer facing side, and for a very simple reason. The blockchain is for multiple parties that do not need to trust each other due to their commercial interest. So the rest of the value chain is it's a more narrow counterparty environment. But when you get to trading, where you get to retail, when you get to wholesale, where there's a burst of the number of the parties and the proportional burst of their interests and interests that may be, commercially contradicting each other. So it's mostly the front, if you will.
To start by trying to explain why would we use blockchain, because blockchain adds that element of trust where, because it's an immutable database, both the party that is buying the service and the supplier that is supplying the service can trust a common source of data. The key information that we're keeping on the blockchain, most of the information is kept off-chain, but the pieces that are needed for legal enforceability, those are the pieces that we keep on blockchain. So what was the tank level when the service request was sent? What was the flow rate? These are key information basis which a service order can be automated. Today, there is a pumper or a company man who is looking at the tank levels in their SCADA, and then they pick up the phone and they call the supplier and say, hey, send a truck tomorrow at 10 a.m. We are now calculating and saying, send that truck tomorrow at 10 a.m. So we're keeping that key data so that if somebody were to dispute, hey, you did not send the service request, or why did you send the service request? That's on the blockchain. Of 100 data elements, one is going to the blockchain. So if you think about, we are tracking that truck and every minute we get 5 readings, or we are looking at the tank levels and every 5 minutes we get a reading. We're not putting all of that onto the blockchain. When there is an event that is important for the automation part of it, that's when we put it into the blockchain. And that's when the consensus mechanism comes in. 99% of the data stays off-chain. Sometimes it is shared bilaterally. It is only the pieces. We are using the blockchain very pragmatically. So we're using smart contracts where it is important as part of the procure-to-pay process. Realizing that, we took the approach of what would it take for the two companies to be able to stop having people mechanically sign. And that's that trust part. So by using the blockchain with these key pieces of data, where we have proven repeatedly that piece of data, so maybe the driver did something or the field personnel did something, they're the only ones who know it. So the guys who are signing after that person, they're signing blind. They don't really know. And so what we've done is take a picture. Now you know what happened. Look at the geotags. Look at when the geofences were breached, so that you know where was the person when they said they did a job. Were they actually over there? If you replaced a piece of equipment, take a picture of the old equipment, take a picture of the new equipment. And so we are creating these evidences which allows for automation. I don't like single unified architecture because that reduces innovation. By having competing architectures, everybody is continuously improving, everybody is competing. So in those cases, what I look for, and this is a word I'm sure you've heard, interoperability. So it is more important that we have interoperability so that those efficiencies can be brought than it is to have a single architecture. A single architecture would bring down the cost, but it would potentially also bring down innovation. It would potentially bring down improvements. And so I would rather take the extra cost of having multiple implementation architectures, so long as they were interoperable and that interoperability was made very, very cheap. So that's an opinion. That's my opinion. I don't know how you feel about that.
Perfect.
In the world before VAT, what they would normally do is a BP trader would call a shell trader, they'll exchange some details, each of them would pen these details down on pieces of paper, and then effectively feed this information back into their ERP systems. And from there on, the whole process of this trade manifesting into actual physical movement of crude oil and ultimately through to settlement would manifest. But the process would be effectively a black box for each participant. Each participant would have their own processes on their own systems, and the other participants would not know as to what is happening. So when they needed to know some information about the trade, they would have to know, they would get to know that only by exchanging emails or phone calls or talking to someone. But what they have now done is they've implemented blockchain ledger as a common minimum system between all these participants, where the whole trading process of agreeing on a trade, the quantity, the price points, the quality parameters, etc., are actually agreed on ledger real time, and this information is then also fed back to the backend ERP systems as the need may be. The essence here is that the information that is now relevant for all the participants in the in this commodity trading process is available on ledger, and everybody has real time access to that information. The whole process of green energy certificate generation today, or the buy and sell today, is fraught with some problems, and these problems could be about double spending. So basically, if I'm buying a green energy certificate from somewhere, I have no guarantee that the certificate has not been sold to somebody else also. Or I also have no guarantee whether the certificate that I'm buying is actually being generated from a green source or not. And with blockchain, with the element of tokenization, we are able to actually give complete proof and provenance of every green energy certificate from its source till it expires. The oil and gas consortia based in Houston recently completed a pilot for automating the water management at one of the oil fields in Bacon Shale in North Dakota. So they completed a POC already on blockchain for authorization of expenditure. So this POC now has further plans of expanding into a more foolproof solution, taking into account asset management, taking into account hydrocarbon accounting, and also integrating the digital letter of credit. The ROI is not necessarily defined only by what you are getting in terms of financial benefits back. It's also about your process efficiency, right? So in certain cases, we have taken use cases wherein, for example, invoice settlements for third-party logistics providers using traditional mechanisms, using traditional ERP systems and EDI infrastructure would take close to around 2 to 3 days. And with blockchain, we have been able to do that process in under 2 to 3 minutes. So that's close to around 98-99% efficiency straight away. So if you look at from a oil and gas company's perspective right now, all the major oil and gas companies are focused on renewables. All of them are talking about a renewables future. All of them are talking about reducing the carbon footprint. And that's where you see the likes of the Shells and BPs of the world very heavily investing in the utility space and the renewable space as such. For example, Shell acquired Applied Blockchain, which was a blockchain company. BP is increasingly working on blockchain. The Chevron, Total, Saudi Aramco, all of them joined the VAT consortia. So from an oil and gas perspective, I think the focus would be in investing in renewables, in investing in use cases in EV charging, investing in use cases in green energy, and that overall element of sustainability. The essence here is to look at the business process, understand the business process in detail, and understand how blockchain can amplify the business process, not just look at it purely from a technology perspective. So that would be the key. The oil and gas industry, or rather in general energy industry, so oil and gas, utilities, mining, etc., has been one of the front runners in terms of embracing blockchain and making it mainstream. Right? So we have seen, for example, a lot of use cases being done in banking. Banking was one of the first and foremost industries to sort of embrace blockchain, but we have seen far less production grade implementations from a banking perspective as compared to what we have seen in the recent past in the energy space, right? More meaningful, more concrete, and outcome driven. I would expect that to grow, at pace. And we, being in the industry and talking to a lot of these customers and partners, do see that increased appetite in terms of making use cases worthwhile. What we are also seeing is a cross convergence of use cases, right? So not looking at use cases in silos, but looking at use cases which cut across multiple functions enterprise-wide, and how do we bring in that streamlining, between these multiple siloed enterprise systems which are existing today.
I talked a bit about the Genesis transaction, the world's first blockchain commodity royalty transaction. And what I wanted to point out here is that talk a lot about the team sport that is blockchain, and how one simple transaction, in this case an oil royalty transaction between a royalty owner called Prairie Sky and a royalty payee called NAL. Now both of these are large companies, large public companies. So of course we had a lot of assurance and a bank to work with us, was to create this blockchain network called the Energy Block Exchange, where we could run multiple use cases using the same network level of services in order to execute these contracts, but then allow us to include different contract types and not have to hard code or recode our solutions in order for them to affect these different contract executions. The concept of a distributed, autonomous, and an organized sharing of all of these things. So I wanted to include this slide because it kind of talks about the evolution that is supported by blockchain here, which is all the way from traditional manual processes that are stuck in these fragmented silos through a series of digitizations into reconciliations and automation, and ultimately into smart contract automation, to move us towards this concept that we can share our tools, and we can share our processes, we can share our data. We can also share these organizations, how we assemble assets, how we actually ascribe assets into hierarchies. We start sharing that, and it allows us to get to a more automatable state. The transitional step, as you start to introduce automation around the data and making sure that the internal data streams start to be improved, you can already get to a 95% efficiency factor just by reducing the amount of resources, by starting to put automation into the reconciliation efforts. And we saw that drop down to then only 13 people in the payor, 7 people in the payee, with 9 critical automations. But this is where it really starts to take value and really delivers core value, is a 400% efficiency factor when you see a full implementation. And you can see how the streamlining of this is now down to 5 people in the payor and 5 people in the payee. And you can see we've eliminated a whole bunch of context, and we've been able to produce an efficiency rate factor of 400% over when we entered. Why governments have such a tremendous opportunity with blockchain is that the infrastructure that's put in between the companies to share data starts to get to a scenario under which we can use as the people's influence and the people's interest through the government. They can monitor those transactions much easier than they ever could before. So if you put a regulator node on a blockchain network and allow a data share with the government regulator, then the government does not have to keep their own infrastructure, and they've been very poor at keeping that infrastructure up to date. So I think that's the important thing there. Yeah, it's one ecosystem. There can't be all these provincial, regional, jurisdictional truths. There needs to be one truth. And this is a problem throughout as digital technologies are maturing and being deployed. And we see this across industries and across societies. It's not that we're all recording the same thing. And I'm not going to go too nerdy and get into quantum observers, because there might not be anything called objective truth when you look at quantum. but I'll just stick to the facts of a running system. There should only be one reporting on a running system. The minute there's more than one reporting, you have more than one truth, and that can't be, right? So quantum effects aside, there should be ability to ascribe the same measurement data across counterparties, and that's what I mean by one truth. In the blockchain world, the spike is getting them to agree, right? Once they agree, though, we have the mechanism under which that we no longer have to trust, because we've replaced the requirement with trust with a system, right? And the minute we can agree on that system and agree on the contract interpretation, I no longer have to worry that the joint venture operator is giving me a line of goods. I kind of view it like a federalist versus a province in some cases, because blockchain then needs to be the federal. It needs to be federated across all of these different. And the most effective deniers or rejectors of this transformation are tied to their local truth, right? This is the way we've been doing it for 30 years. So you've got to fight 30 of those. If you want 30 counterparties, you're fighting 30 local truths or local narratives about what's happening, because you're trying to stretch something over here across all of it. So that's part of the adoption challenge here, is that you have to be right at an industry level. They only have to be right inside of their office.